Hi, in this video we're going to be looking at areas of a triangle. Okay, so I've just got a little demonstration here for you. Now this particular triangle, so that's a right angle triangle, and if I drag that anywhere along that line to over here to make another right angle triangle, the area is in fact exactly the same. Alright, so if you could do if you're not quite sure about that, you could prove that for yourself. But that's the truth. Alright, now just to show you another little way, here's a nice right angle triangle, no matter what size I make it. Okay, and if I slide that around over here, what sort of shape does it make? Well, it makes a parallelogram or a, you could say it's a rectangle. So it's a half of basically what a rectangle or a parallelogram is going to be. So if I just slide that back and try and make it a nice little right angle triangle, don't know if I can do that. That makes probably closer. You can see it's more of a rectangle there. So a triangle is basically half of a quadrilateral, half of a square, half of a parallelogram, half a rectangle. Alright, so that's what we sort of want you to understand from there. Right, what you're probably used to in earlier years of high school, area of a triangle is half base times height. So I've got three identical triangles here. We're going to use the three different methods to do the area. So this is a right angle triangle. I'm making an equilateral, so that would be 2 there. That would make that 1 there, and by using Pythag you could work out that there is √3. Alright. So the area of that particular triangle is going to be half the base. Now the base is 2 times by the height, which is √3. And so therefore cross, that's going to give me √3, which is essentially 1.73 units squared. The units squared, aren't they? Alright, so that's what you've probably been used to doing beforehand. And that requires you having a vertical line, and as I showed you before, we can move that line across and it'll still be the same area. This one here, this another technique, is using an idea of our triangle half AB sine C. So the angle between two sides allows you to work out the area of the triangle. So this side over here would be 2 meters as well, because it's an equilateral triangle. So what we're going to do here is simply put our values in there, half of 2 times 2, and if it's an equilateral triangle, all the angles are 60. Alright, I'm going to do that on our calculator. Come over here and we'll just clear that. So a half of, so 0.5 times 2 times 2 times sine of 60. And that gives me 1.34. Now, just to check that it's the same as √3. √3 is the same answer. Alright, so that gives me the same answer. Beautiful. So that's equal to 1.73 units squared. Now the great thing about this one here is you don't need to have a perpendicular, and as long as you've got an angle between two sides, you can actually work out the area. The third one is the formula when you don't have any angles and just have all the sides. So what I'd have to do here is work out the semi-perimeter. So that will be the sum of all those sides. 2 plus 2 plus 2 is 6 divided by 2 is going to give me an answer of 3. Well, the area then is going to be 3. And that'll give me 3 take 2, 3 take 2, 3 take 2. Now 3 take 2 is 1, so that's going to give me the answer of √3, which is equal to 1.73 units squared. So I've given you 3 techniques to find the area of a triangle. Now you'll find that you'll have to do these calculations depending on what the information given to you. Alright, so that's the bonus of it, I suppose. Just want to set you a challenge. Okay, the challenge would be, if I give you a quadrilateral, I'm going to draw one in here. Okay, I'm going to draw a quadrilateral in here. Oh, actually, it doesn't need to be quadrilateral. Just going to do a shape. Right, so that's my shape there. Get rid of the fill in there. Don't really want to fill. Alright, so if I want to work out the area of this particular shape here, well, what I could do, the easiest way of doing this is to break it into some triangles. Okay, so I'll just show you how I do that. Alright, so just insert some lines. I'll just pick a line at any point to start from, draw a line there. Okay, and then I would draw another line. So if I make this into triangles, I can solve the area of a triangle, can I? Right, so that's probably the big thing over here. And I could do a survey. This is called a radial survey. If I knew the lengths between each of these places, each of these bits. Right, so if I knew the length of the lines and I knew the angle, then I could easily work out the area of this whole shape. And so breaking things into triangles makes life much easier for us. So all I'd have to do is, let's say I worked out this angle here, worked out to be 80 degrees, that there was 40 meters, that there was 50 meters, then, and I call this section number 1, then all I'd need to do to work out the area section number 1 would be to use my formula. So that'd be a half of 40 times by 50 times by sine of 80 degrees. And you could go to your calculator and you could work that out and get an answer. And then all you need to do is keep repeating that whole process. So it's a really useful way of finding the area out of irregular shapes by breaking it into triangles. All right, so that's a big clue for what we're doing there.